In this video, I'm going to show you how to perform a descriptive statistics analysis using the Thotsakan Statistics tool. To do that, I'm going to use the dataset from Kaggle um, League of Legends Diamond Rank games, which has 10,000 games of League of Legends. So this is our initial interface of the tool. I'm gonna take the data and read it over here. So it has been loaded. We can see that it has been correctly loaded over here. So it has different columns, this data set. For example, if in this game the blue team won or didn't won, um, how many words was placed, how many were destroyed, and so on. Directly from here, we can get a summary. So this works directly as a descriptive analysis pretty quickly. So for example, we can see that uh, the average of the games in which the blue team won was around 50% of them. It tells us the standard deviation, the minimum, the maximum, and the um, quintiles. I'm going to be using this blue total gold variable in this example. So on average, the amount of gold that the blue team makes is around 60,000 gold. This is standard deviation. The minimum in these games it was of 10,000 or almost like 11,000, and the maximum was 23,000. And these are the quintiles of the first quartile, the median, and the third quartile. So right immediately from here, we already got um, descriptive statistic analysis, but we might want to have like a more in-depth uh, analysis. So we can come to this estimation tab, refresh the columns, and I'm going to select the the variable that I set. So where is it? Blue, gold, blue, blue total code. So I'm going to be using this one. So um, we have this tab over here, which is graphical analysis, and there are two graphs that we can create. We can create a histogram, or we can plot the empirical cumulative distribution function. So um, I think that it's more common to see the histogram than the cumulative distribution function. So I'm gonna plot it here. And we can see the histogram over here of how many gold the blue team got. Um, so this is a histogram, and this curve in purple is the kernel density estimator. So we can add it, or we can not add it. We don't want to add it. We just uncheck this one. So we're gonna get just the histogram, right? Over here also, we can show the data, which in this case there are so many that there should be around here all the data. You can explore this in more detail in the examples. Uh, this is what we got by default. So this is already also a descriptive statistic, which is the histogram and the kernel density estimator, which what they do is to estimate directly the density of the observations. Or we can also plot the empirical cumulative distribution function. We have here the option to add confidence intervals. For now, I don't want to create confidence intervals. So I run it. And this is the empirical cumulative distribution function. Um, if we click confidence intervals and run it, There's over here a small branch around a small brand or a small interval over here around the empirical cumulative distribution function that tell us our uncertainty about this function using the Dvarietsky-Kiefer-Wolfowitz inequality. We don't have to worry about this for now. So this is just a empirical cumulative distribution function and a histogram over here. Okay, so we can come now to this descriptive analysis tab. We refresh the columns and we select the column that we want, which was blue total code. And on this part, we can select which statistics we want to calculate. For example, we can calculate the quartiles, and this is giving us the value of the first quartile, the second or the median, and the third quartile, right? We can select quantiles and we can say of any probability that we want, for example, of 10%, 20%, and 90%, or more. For example, we can also add 45% and run it, and it is giving us the quantiles of those probability 10%, 20, 45%, and 90%. We can ask for um, central tendency statistics. So we run it, and it is giving us the value from the mean, the median, geometric and harmonic mean, the green mean, whose parameters are controlled over here, the winsorized mean, whose parameters are controlled on this other box, the interquartile mean, and if we passed weights over here for every single observation, it will calculate a weighted mean. In this case, I didn't pass any weight, so that's why I don't get any value over here. Since this data set has 10,000 observations, I will need to put right by hand here 10,000 weights, which I'm not going to do. And it is also telling us if the data is robust or non-robust on this other column. So for example, we have that the median is robust, the mean is not, the twin mean is robust, the interquartile mean and the winsorized mean, they are robust statistics. We can calculate dispersion statistics that estimate the standard deviation. So we run it, and it gives us over here the value of the deviation with 0 degrees of freedom, 1 degree of freedom, the range, the interquartile range, the MAT, and the AAD. And the second column is giving us the value um, correcting for the bias. And uh, finally, the third column telling us which statistics are robust or which statistics are non-robust. Which in this case, there's not much difference because we don't have outliers in our data set. So most of these variables, once we correct by bias, they are estimating the standard deviation. Uh, we don't have like any case in which some outlier modifies significantly any of them. This data set does not have outliers, so we didn't see any outlier directly from the histogram. We can calculate the skew, so we run it. We see that there's some positive skew, right? So it's not completely uh, symmetrical, and the kurtosis. So it is giving us the kurtosis, and it is giving us the excess of kurtosis, which in this case it looks pretty much around 3. So probably a normal distribution could explain this data pretty well. Or we can select all the descriptive statistics, and it will calculate quartiles, central tendency, dispersion, skewness, and kurtosis over here. So this is the whole summarized of our descriptive analysis. Once we have these statistics, we can come back to graphical analysis. And now we can add a normal density over our histogram. We get here a warning that says that first, perform a descriptive analysis for central tendency and dispersion. That we already did. We need to do that. That is, we need to come to descriptive analysis and perform a central tendency and dispersion. Because if we want to add a normal density, we need to say what is the value of mu and what is the value of sigma, or how are we estimating mu and how are we estimating sigma. So we can select here any of these statistics, for example, the mean, and over here also which statistics we are using for the deviation. And this is already corrected by the bias. So I'm gonna run this, and now we can see this is the normal distribution that is centered in this value in the sample mean, and whose standard deviation is given by this estimator. We can change to other statistics. We can use, for example, a robust one like the interquartile mean, which is not going to make too much difference because again, there are no or we don't see any outlier over here. So probably there's not going to be we will not observe uh, a significant change in the form of the normal density. And same here, we can select robust statistics like the MAT and run it. And yeah, essentially it's the same, but this new normal is centered on this value, and the standard deviation of this normal is given by the MAT. If we come back to the empirical cumulative distribution function, we can add now the cumulative distribution of normal density. Again, this is the same warning, which is saying that we need to say what is the value of mu and what is the value of sigma. So if I run it like this, we got this, which is telling us again like a graphical summary. Uh, So it looks pretty much that the normal distribution is a good approximation for this variable. And we can come to the histogram and run it, and we got something like this. So we can see graphically uh, how this looks like, and over here in descriptive analysis, we can have like all these statistics. We can also save these results. If I say, for example, over here something like descriptive analysis, this better say something like all statistics. And I'm gonna put something like lol games, and I click save the table. It's gonna save the table as a CSV. Wherever I am running this in that file is I can find now this table, all statistics load games .csv, and also the pictures I can save them, so I can also give over here something like um, graphs load games and save it. So I will have now a picture of graphs log games .png. And that's it. That's how we can perform a descriptive analysis using the Thotsakan Statistics tool.